Welcome back, everyone. In this video, we're going to learn about vapor pressure and the effect that temperature and intermolecular forces have on vapor pressure of a substance. Then we'll take a look at what we mean by the normal boiling point and evaluate the effect of external pressure on the boiling point of a liquid. So vapor pressure is the pressure exerted by a vapor when that vapor is in equilibrium with its liquid or solid phase. Now, what do we mean by a vapor? Let's imagine that you have a liquid in a container. And initially, the molecules of that liquid all are in the liquid phase. Given enough time, what will eventually happen is that some of the molecules' particles will evaporate and convert into gas. The pressure of this gas at that point, once it has reached the maximum amount, we call the vapor pressure. So a vapor is essentially the gas that is produced by a liquid or a solid due to that liquid evaporating or solid subliming. So we can discuss the relative rate of evaporation versus condensation. Initially, the molecules are only evaporating. However, given more time, we also would have gas molecules that are converting back down into the liquid state. They're condensing. The point at which those rates are equal to each other is what we call dynamic equilibrium. So we have two opposing processes: evaporation, where the liquid molecules are converting to gas, and condensation, where the gas are converting back down to liquid. Once those rates are the same, that's what we call equilibrium. And so during the process of equilibrium, there's no net change, even though the molecules are continuously moving in between the different states of matter. So this is similar to the idea of going to a grocery store. When the grocery store initially opens up, there's only going to be an influx of people. And so the number of people inside the store will increase. Eventually, people are going to finish their shopping and they're going to leave. Once that happens, you have people leaving and people entering. If the rates at which people leave and enter is the same, then the number of people inside and outside the store are going to stay the same, barring any other events that could occur. So that's another example of equilibrium. We're looking at opposing rates or opposing processes that have the same rate. Again, looking at this particular example, we're looking at evaporation and condensation being the two opposing processes. When the rates of the two processes are the same, we call that dynamic equilibrium. Let's now talk about a term called volatility. Volatility describes the ease in which a substance will evaporate. So at any given temperature, if a substance has high volatility, then it's going to have a higher vapor pressure. This should make sense because if it's volatile and it's evaporating, then there's going to be more molecules leaving the gas phase to the liquid phase and able to stay, or excuse me, leaving the liquid phase to enter the gas phase and able to stay as a gas. So the overall pressure will be larger than for molecules that have low volatility. Let's now address what would cause differences in volatility. When we looked at kinetic molecular theory, we saw how for a given collection of gas molecules, there's going to be a range of energies or speeds at which each gas molecule is. And we can understand the relationship between temperature and vapor pressure, as well as intermolecular forces and vapor pressure, by looking at a Boltzmann distribution for different for gas at different temperatures. So if we're talking about a liquid, what's going to happen when the temperature increases? The vapor pressure will increase. The reason for this is because at a higher temperature, then the average kinetic energy is going to increase. Therefore, there's going to be more molecules that have the minimum amount of kinetic energy that's needed in order for them to leave the liquid phase and enter the gas phase. If we're keeping the temperature constant, but if we are looking at different substances, we can evaluate how intermolecular forces will affect it. If a substance has weaker intermolecular forces, then it will have a higher vapor pressure. The reason for this is because if the intermolecular forces are weak, then there's going to be a lower threshold of kinetic energy that's needed in order for them to escape the liquid phase and go to the gas phase. As we saw earlier, vapor pressure is going to be a function of temperature. This plot looks at just that. We see for a variety of different substances, what is the pressure of that substance as a function of the atmospheric temperature. You're probably not familiar with camphor or diphenyl ether, but these are large organic molecules. All of the other ones, ethylene, dimethyl ether, diethyl ether, ethanol, water, and iodine, you should be able to figure out what they are based on their name. If you don't, then I would recommend looking them up. At 1 atmosphere, this is what we call the normal boiling point of a substance. And the normal boiling point is the temperature at which the vapor pressure equals 1 atmosphere. And the reason for this is because a substance boils when its vapor pressure is equal to the atmospheric pressure. So if you go higher in elevation, this is what causes substances to have lower boiling points. At higher elevations, the atmospheric pressure is lower. Because the atmospheric pressure is lower, the pressure that a substance needs to achieve in order to boil ends up being lower. So if we lower our atmospheric pressure down to about 0.6 atmospheres, we can see that the temperature at which a given substance boils is going to be lower than at the higher atmospheric pressure. So let's do a practice problem here. Looking at the graph, which substance would you expect to have a higher vapor pressure at 300 degrees Kelvin? Pause the video and try this on your own. Welcome back. So to evaluate this, what you can do is you can look at these data points on the graph. So if we're talking about 300 degrees Kelvin, that is this vertical line. And if we're talking about ethanol versus water, what we can do is compare what is the pressure of each substance at that temperature. And what we see is that the ethanol has a higher pressure than the water does at that same temperature. What that would mean then is that ethanol must have a higher strength of intermolecular forces compared to water. That's it for this video. Thanks for watching. Have a great day.